Okay, so let's now start with problems. Okay, I'll start with problem number 2. Is it visible? This, can you read the questions,
Yes, sir.
or should I
Yes,
make
sir.
it bigger? Little
No,
bigger?
sir, it's okay.
Sir, it's okay, sir.
Okay, let's start with question number 2. Question number 1 is easier. A die is rolled once. Die is a singular of dice. A die is rolled once. Find the probability of getting, and you have 3 questions here. Okay. So first of all, whenever what is the random experiment here? Die is rolled once. So we'll first write the sample space. Sample space S. If a die is rolled once, what are the how many outcomes are there? Either 1 or 2 or 3 or 4 or 5 or 6. So what is the total number of possible outcomes? The number of elements in this set.
Sir,
Total number of possible outcomes, which is 6, right? Okay, now we'll answer the first question. If you see, the first question states find the probability of an even number. Now, because your question is an even number, we'll define this event accordingly. So let E1 be the event. Let E1, and we can give a colon here. Okay, and we define this event as appearance of an even number. Now you know that any event is a subset of the sample space. So therefore, what is E1 here? From the sample space, which elements am I going to select? 2, 4, and
2,
6.
4, 6.
So 2, 4, and 6. This is my event. So number of events, number of outcomes favorable to the event, number of outcomes favorable to the event E1 is how many? How many elements in this set? 3. So therefore, now because we have got both, therefore we'll write probability of E1. You can either write this way, or you can also write probability of appearance of an even number. Probability of appearance of an even number is number of outcomes favorable to the event is how many? 3. And total number of possible outcomes is how many? 6. So your probability is half. Any question?
No, sir.
Okay. Now look at number 2. The second question here is uh, find the probability of getting a multiple of 3. So what we do is we define the event E2, because even we are already defined. So we'll define the event E2 as appearance of a multiple of 3. Right? So what is E2 here? In this case, which will be the set E2 from the sample space? Which ones are the multiples of 3? 3 and 6, right? These are the multiples of 3. So how many outcomes favorable to the event E2? How many events in E2? There are 2 events, right? So therefore, probability of E2, PE2, that is appearance of a multiple of 3. Appearance of a multiple of 3 is how many events favorable? 2. And total number of possible outcomes? 6. So 2 by 6, which is 1/3. Okay. Any question? Next question is not a multiple of 3. So I define this event accordingly. My sample space remains the same because my experiment is not changing. So if I define the event E3 as appearance of not a multiple of 3. Therefore, what is my event E3 here in this case? Which ones are not multiples of 3 in the sample space? 1 is not a multiple of 3, 2 is not a multiple of 3, 4 is not a multiple of 3, even 5 is not a multiple of 3, right? So how many outcomes favorable to the event E3? How many elements in E3?
4.
4. 4 outcomes are there in E3. So therefore, the probability of appearance of not a multiple of 3 is 4 by 6, which is 2/3. Clear? Any question that you have on probability? Find it easy for you. You're finding it easier? Yes. Any question? Let's move to the next question then. Question number 3. Two coins are tossed together. Together means simultaneously. Find the probability of getting, and you have 3 questions: 2 tails, at least 1 tail, and no tail. Okay. So if I first of all we have to write down the sample space, right? So let heads be denoted by H, and tails be denoted by T. So therefore, what is the sample space? All the possible outcomes.
So 2H,
HH,
HT,
HT,
30H, and TT.
TH, and TT. These are the possible outcomes. So total number of possible outcomes is how many? How many possible outcomes? There are 4 possible outcomes.
4.
Right? Okay, once we know the possible outcomes, we'll answer the first question. The first question is at least 2 heads. So we define the event first. Let E1 be the event at least 2 heads. Therefore, what is E1? From the sample space, which outcome has at least 1 head? This one, HH, this has at least 1 head, right? This one has at least 1 head, HT. This one has at least 1 head, TH. TT cannot be taken because both are tails. They don't have any head, right? So number of outcomes favorable to E1. How many outcomes favorable to E1 is equal to how many? In E1, there are 3 outcomes, right? So therefore, PE1 or P,
So, but it's written at least 2 tails.
at least 2 heads is there, not 2 tails. Oh, it's 2 tails. Okay. I was seeing question number 4. My mistake. So we will define the event accordingly then. Our question here was at least 2 tails. So you will define the event as 2 tails. So therefore, what is the event E1 here? Only TT, right?
Yes,
So
sir.
number of outcomes favorable to E1, event E1 is 1. So P 2
Yes, sir.
tails is how much? Number of outcomes favorable to E1, 1. divided by, and how many total number of possible outcomes? 4.
So
So
4.
1/4 is your answer. Okay. Let's see the second question. At least one tail. Okay. So let's define the event E2 is question number 2.
Sir, can you please explain these sums once again?
Yes, that's what I'm doing. Question number 2, if you follow, you can follow question number, all the other questions also. At least one tail, right? Listen to this very carefully. Sample space remains the same because my experiment is not changing. My random experiment, sorry, not this one. I'm talking about this one. At least one tail. So the random experiment remains the same, right? I'm not changing the experiment, isn't it? 2 coins I'm tossing,
Yes,
and
sir.
that remains the same. So sample space remains the same. But my question is changing for question number 2. So I will define the event accordingly. So I will define the event E2 because E1 I have already answered in one. So I'll define the event E2 as, what is the given question here?
At least one tail, sir.
At least one tail. At least one tail. This is the given event, right? So E2. Okay. Who was asking this question that explained the sum?
Sir, me, sir.
Okay. Go ahead and now tell me what is this event? At least one tail. Which one should I select from the sample space? Which
Sir, head,
outcomes?
tail, and tail head.
HT, TH. At least one tail. Why can't we have TT? At least means
Sir,
minimum one, isn't it? So we have
yes,
two.
sir.
So we can
Yes, sir.
accommodate that also, right?
Yes, sir.
So
Yes, sir.
how many outcomes favorable to the event E2? How many outcomes in E2?
Sir,
How many
3.
elements
Sir,
in
3.
E2? 3. So therefore, the probability of E2, or probability of at least one tail, is equal to 3 number of outcomes favorable to E2 divided by total number of possible outcomes, 4. Is this clear?
Yes, sir. Sir, we have to
Hmm.
write this P is equal or P bracket at least one tail.
You can either write this or you can write this, any one. Okay, I'm showing you both ways. Okay, so let's answer the third question. Question is no no tail, right? Yes, no tail. So I defined the event E3. So because my question is probability of getting no tail, I defined the event E3 as no tail, right? So E3 will be how many events in the sample space which contain no tail? Only
Sir,
HH, right?
1.
Only HH.
Yes, sir.
So how many outcomes that are favorable to the event E3?
Sir,
How many
1.
elements? 1.
So,
So probability of E3 or the probability of no tail should be how much? Probability of no tail should be
So 1/4.
so
1
one
by
fourth.
4. 1 by 4.
1/4, sir.
And that should be your answer, right? So that was easy enough. Okay, let's answer question number 4 now. The question here is 3 coins are tossed together, find the probability of getting, and you have 3 questions. Okay, let's first concentrate on the random experiment. 3 coins are tossed together. So if I denote heads by H, tails by T, then what should be my sample space? I told you when 3 coins are tossed, what should be my sample space? All can be heads, H, 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 right? I can have H, H, T, I can have H, T, H, I can have T, H, H, right? What else can I have? I can have HTT, right? I can have THT, I can have TTH, and I can have all tails. Any other? No. So how many possible outcomes? 2 cube, right? Which is equal to 8.
Yes, sir.
So we'll now focus on the event. We'll now see what the question is. Once I have written down the outcomes and I have um, written down the sample space, now I'll focus on the questions. Now, if you see the questions, the first question is probability of getting at least 2 tails. So I define the event E1 as at least, because my question is that probability of at least 2 tails. So I define my event E1 as at least 2 heads, sorry, not tails, at least 2 heads. Okay. So therefore, what is my event E1? At least 2 heads. Okay. Among these, can you tell me which one has at least 2
So
heads?
H, so
Yes.
triple H and HHT and HTH.
Sir, first 4.
At least 2 heads. Yes. First 4.
Yes, sir. First 4.
HTH. THH. Right. And no other. So number of events favorable to E1 or number of outcomes favorable to E1. Number of outcomes favorable to E1 is how many? 4. So therefore, probability of E1 or probability of at least 2 heads. How much should it be?
Sir, 4/8.
4 by 8, which is equal to half,
Half.
right? So there's only 50% chance of getting at least 2 heads, right? Okay. Next question is at least 1 tail, right? So let's see, at least 1 tail. Let us define the event first. Event E2. We define our event accordingly. At least 1 tail, right? And therefore, what is my this is E2, and what is my set E2 then? Okay, look at the sample space now. How many outcomes have at least 1 tail? HHT has at least 1 tail, right? Isn't it? HTH, at least 1 tail. THH, at least 1 tail. HTT, there are 2 tails. We need at least 1, so that's we can take this. THT also, TTH also, and TTT also, right? How many outcomes now favorable to the event E2? 7, right? So what is the probability of E2? Probability of at least 1 tail. How much should it be? Probability? 7 divided by
7 by 8.
8, right? And that should be your answer. That answers question number 2. We'll now see question number 3. What is question number 3? It is at most 1 tail. What do you mean by at most?
Sir, most to most 1 tail.
That means no tail or 1 tail, right?
Yes, sir.
Isn't it? At most 1 tail. So we define the event E3 as at most 1 tail. Now, let's see from the sample space. What should E3 be? See and tell me how much should what should E3 be? Which has no tail?
So triple H.
Yes.
Sir,
HHH.
second, third, and fourth.
So then HHT,
Yes.
HTH,
Yes.
THH.
THH.
Sir,
And we
right
can't
side,
take the others. Why can't we take the others? because they have two tails. We need
Because it
at
has
most
two.
one. That means either no tail or one tail only. So if you see all these, HHH has no tail, right? HHT has one tail. This has one tail. This has one tail. So we have taken everything. So how many outcomes in E3? There are 4 outcomes in E3. So therefore, what is the probability of at most one tail?
Sir, 4/8.
4/8, which is equal to half, right? So that answers the second question also. Okay. So let us move to the next sum, which is number 5. This time the experiment has changed. Okay. In question number 5, the experiment is with 2 dice. When 2 unbiased dice are rolled, then what is the sample space? See, the question states 2 dice are rolled simultaneously. Find the probability of getting, and you have 3 questions. So your random experiment here is 2 dice rolled simultaneously, right? So what are the possible outcomes in this case? S, sample space. If you remember, in my examples, I had written the sample space. You can either get 1, 1 on both the dice, 1, 2 on both the dice, 1 in first, 2 in the second, 1 in first, 3 in the second, and so on. This will continue till 6, 6, right? So total number of possible outcomes is how many?
36.
6 square. Total number of possible outcomes is equal to 6 square, which is equal to 36. So I've got the total number of possible outcomes. Let's now see the questions, and we'll define the event accordingly based on the question. If you see, the first question is the sum as 7. So first I define the event as the sum as 7. The sum as 7. So therefore, what is E1? So which outcome from the sample space should I select so that the sum of numbers appearing on both the dice is 7? First of all, what can I select? I can select 1, 6.
So 1, 6.
And you also have a 6, 1, isn't it? 1 in the first,
Yes.
6 in the second, or 6 in the first, 1 in the second, right? Okay. What else can I have? I can have 2, 5,
2, 5.
and I
So
can
2,
also have
5.
5, 2. I can also have 5,
Yes.
2, right? Okay.
Yes.
Next, what can I select?
Yes,
I can
sir.
have 3, 4,
So 4, 3.
and 4, 3 also, right? Next, what can I have? I can have none. I don't think any other will give you a sum of 7, right? So this is the total.
Yes.
So number of outcomes favorable to E1. Number of outcomes favorable to E1.
So 6.
There are 6. Hence, what is the probability of getting a sum as 7? PE1 or
So 6 by
P
36.
the sum as 7.
So 1 by 6.
Yes. So this is 6 by 36, isn't it? So this is 1 by 6. Right? So that finishes the first part. Okay, we have time for the second part also. So let's finish the second part, and the third part we'll finish tomorrow. The question is the sum as 3 or 4. Okay, the sum as, so we define the event E2. The sum as 3 or 4, right? So this is my E2. And what is the event E2? The sum as 3 or 4. How can I get the sum as 3 or 4? What are the outcomes which will give me a sum of 3 or 4? I
So
can get
1, 2.
I can get 1, 2, which gives a sum of 3, and I can also have 2, 1, which will give a sum of 3. 4. In how many ways can I get 4? I can have 1, 3.
So 2, 2.
Yes,
So
I can have 1, 3. I can have 3, 1, right? And I can also have 2, 2.
Yes.
Any other?
Yes.
So because this is
Yes,
OR, that is why I've taken the sum as 3. These two will give me the sum of 3, and these 3 will give me the sum of 4. So because there is an OR here, that is why I've taken all. Okay. So how many outcomes favorable to the event E2? How many elements are there in E2? 5.
So 5.
So what is the probability of E2? The sum as,
So 5 by 6.
Sir, 5 by 36.
yes, it should be 5 by
Yes, sir.
30.
5 by 36.
The probability of E2 sum as 3 or 4 is equal to 5 by 36. And that should be your answer. Okay. Do we have time for the third one? Perhaps I have time for the third one also. But let's finish the third one. Let's finish this question. E3. Let us define the event E3 as prime numbers on both the dice. Okay. Prime numbers on both the dice. E3. What is my set E3 from the sample space? Can you say which numbers are prime on both? First of all, I
So
have
1, 2.
1 is neither prime nor composite, so you cannot take 1. Okay. So
Okay,
1,
sir.
1,
Okay.
1, 2, 1, 3, 1, 4, 1, 5, 1, 6 are all out because 1 is neither prime nor composite. So forget about that. First one is 2, 2, right? 2 is an even prime.
Yes, sir. 2, 2.
Next, I can have 2, 3. Right?
Sir, 2,
I can
5.
have 2, 5.
Yes, sir. 2, 3 and 2, 5.
Next, what can I have? I can have 3, 2.
Sir, 2, 7.
I can have 3, 2 also, right? I
Yes,
can
sir.
have 3, 5, right?
Yes, sir.
What else can I have? I can have
Sir, 2, 7.
uh,
Oh, no, sir. Sorry, sir.
4, 3, sir.
4, 3 is not possible. No, 4 is not possible because 4 is not a prime number. So 4, 1, 4, 2, 4, 3, 4, 5, 4, 6 is not possible, right? Next, 5,
Oh,
1
so
is
5,
5,
3.
5, 1 is not possible. 5, 2 is possible, right? Next, what is possible?
5, 2, sir.
5, 3 is possible.
So 5.
5, 3.
Next, 5, 4 is not
So
possible.
5,
So
5.
5, 5 is possible. 5, 6 is not possible. Next, 6, 1, not possible. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, not possible because 6 is not a prime number, right? So this is the only set that we are going to get. Clear? So how many
Yes, sir.
how many outcomes favorable to the event E3?
So 8.
Sir, 8, sir.
8. So what is the probability of E3? Which is prime numbers on both the dice. Remember to give the quote sign, okay? So this is 8 by 36. Okay, so you can cancel this with 4, which is
Sir, 2 by 9.
2 by 9 should be your answer. Okay, so that finishes question number 5. I thought I could not finish question number 5, but I finished question number 5. So I'll continue with question number 6 tomorrow. Okay, I'll stop here.